Okay, so Wednesday is our midterm. Today is just going to be reviewing for that midterm. Tomorrow, since your TA does his sessions on Wednesdays, you won't have a problem session before the exam. So I'll hold online office hours tomorrow from 9 to 10:30 and then again from 1 to 2:30. It'll be on Google Hangouts, so you'll need to have that downloaded. But I'll post a link on Blackboard, so it should be super easy to find. I'll screen share, and then you guys can ask me questions, and I'll do them, or you can send me pictures of your work, and I'll try to figure out where you went wrong, things like that. Whatever is going to be most helpful for you. Yeah. So you don't need to share video if you don't want to. That's fine. You will not be able to see me because I want to stay in PJs all day because I'll be home. And this is the only professional setting in which that's okay. So yeah. Any questions on that? All right. How was the review?
How would you go about turning to part A?
Number 2. So that's like these. So I did this one. This one's pretty easy once you do it,
Okay.
but that's on OneNote. So I'll go ahead and do part C.
Oh, or anything.
Just for the part A's, and then 3 and 4 are on there, and number 6 is on there. So if there's a part A to the problem, just part A is on there. If there's not, the whole thing is on there.
Okay.
And I made it collaborative, so if you have answers to part B, C, or D that you want to post, you can post that right in the OneNote notebook so that other students and I can see and have discussions, which I know is terrifying for everybody, but I still think it's a good idea. So the easiest thing to do for these types of problems, we want to find constants A, B, and C so that this is twice differentiable. So the easiest thing to do is start with the second derivative, because when you take derivatives of that quadratic, some of the constants will go away. So we'll start by taking G double prime. And now I don't know what G double prime is, or if it's even going to exist at x equals pi over 2, but at pi over 2, but everywhere but pi over 2, I know what the second derivative is. So the second derivative of sine is negative sine. Less than pi over 2. And then the second derivative of that quadratic is just 2a. It's a constant. But I can only say that it's that when x is greater than pi over 2, because again, I don't know what's going on at pi over 2. It's possible that we're undefined there. But we can say that the limit as x goes to pi over 2 from the left of G double prime of x, that's just going to equal negative sine of pi over 2. So negative 1. And then similarly, the limit as x goes to pi over 2 from the right of G double prime. This is just going to be 2a. Okay. Now, in order for G double prime to exist at pi over 2, it needs to be continuous at pi over 2. So I need negative 1 to equal 2a, so that a is equal to negative 1/2. So far, so good?
So then B and C don't really matter.
Well, no, because I also need to make sure that the first derivative exists and that the function is continuous. So this is step 1 of 3 steps, which I don't actually remember if they get harder or not, but nevertheless. So next we need to check the first derivative, which again, when x is not equal to pi over 2, is pretty easy to find. The derivative of sine is cosine. So when x is less than pi over 2, our derivative is cosine. When x is greater than pi over 2, our derivative is 2ax plus b, except that I know what a is, so I'm going to replace a with what it equals, and so this is negative x plus b, because 2 times negative 1/2 is just negative 1. And so now it's just a matter of now it's just a matter of finding out what g prime needs to equal at pi over 2. So the limit as x goes to pi over 2 from the left of g prime, that's just going to be cosine of pi over 2, which is 0. The limit as x goes to pi over 2 from the right of g prime, that's just going to equal negative pi over 2 plus b. And that means that b must equal pi over 2. So that the first derivative is 0 at x equals pi over 2. So at this point, I have that g of x is equal to sine x when x is less than or equal to pi over 2, and negative x squared over 2 plus pi over 2x plus c for x greater than pi over 2. Now the limit as x goes to pi over 2 from the left of g of x, that's equal to 1. Final answer. And the limit as x goes to pi over 2 from the right of g of x, I don't know why I'm skipping. There we go. And from the right is negative pi over 2 squared over 2 plus pi over 2 squared plus c, which I'll simplify to 3/2 times pi over 2 squared plus c, so that c equals 1 minus 3/2 pi over 2 squared. Yeah. So now I have values for a, b, and c. The first one is drastically easier though, because it's when x equals 0.
Okay.
So when you, regardless of what derivative you're at, you only have one variable that you're working with.
Alright.
So And also e to the 0 is just 1, so you don't have any irrational numbers hanging out. All right. Other questions?
I think I also like for part C, what is the answer of the same question?
This?
Sorry, like the two, like the same, like under like 2C.
I don't know. Can you tell me what that one is?
It like gives you, sorry, oh wait, I don't know where. Oh wait, I'm sorry, it's 1 part C.
One part C, okay. This one. Yeah. So the answer is ln of 2.
Okay, and then is the answer for the part D, how would you write the answer for part D? Did you just simplify it, or?
How did you find the answer for part C?
Or part D?
How did you find the answer for part C, though?
Took the derivative of the top over the derivative, like.
Oh, no. We don't know L'Hopital's rule yet. Calm down.
Okay, so how did
Yeah.
you find it?
Yeah, so both of these are the same, but this is a little bit easier. Well, this is a little bit harder to see, but the math works out to be a little bit easier. So if we let f of x equal 2 to the x, and we try to find f prime of 0, right? If we just wrote this out using the limit definition of derivatives, this is the limit as h goes to 0 of, right, f of x plus h minus f of x all over h. And this is going to be the limit as h goes to 0. Oh, and I'm sorry, I'm asking specifically at 0, so not x, but 0 plus h, f of 0. And so this is 2 to the h minus 1 over h. So that's exactly what we had. So now if we find the derivative of f, which is just 2 to the x ln 2, then we know what f prime of 0 is. It's 2 to the 0 ln 2, and that is just ln of 2.
Okay, that makes sense. Would you do the same for like part D then?
Yeah, so for part D, it's pretty easy to see what the function is if you look at it, so give it a shot. Take a few seconds, figure out what you want the function to be. All right, what do you think the function is? You want to recognize that this is the derivative of some function at some point. What would the function be?
Is it like the sine of x, or?
Not sine. Because remember, the limit definition of derivative is f of x, not f prime of x,
So it's
right?
just cosine of x?
Close, but that pi over 4 in front, what's it doing?
Is it cosine of x? So 2 pi over 4? No.
It's going to be x.
X cosine of x.
Or second x. Because now, if we try to find f prime of x using the limit definition, I'll change that x to a, and what point do you think we're going to be looking at?
Pi over 4.
So this is going to be f of pi over 4 plus h minus f of pi over 4 all over h. And so that is the limit as h goes to 0 of pi over 4 plus h cosine of pi over 4 plus h. So that's f of x plus h minus f of x all over h. So we're just recognizing that this limit is the derivative of x cosine x at pi over 4. Okay. Now, what is the derivative of x cosine x? We're just differentiating x cosine x. It's the first times the derivative of the second plus the second times the derivative of the first. And so at pi over 4, this is just negative pi over 4 root 2 over 2 plus root 2 over 2. So that limit is going to evaluate to that.
If we wound up writing it like just putting the pi over 4 in with leaving the sine and the cosine, is that alright, or like you want the root 2? Okay.
And this is the first time in the course that I can ask you about this question, because of course when we were talking about the limit definition of derivative, you weren't allowed to know product rule or the derivative of trig functions. And then when we knew product rule and the derivative of trig functions, I was no longer asking you about limit definition of derivatives. So now for this cumulative midterm, it's the first time I can ask you these types of questions. So that's a very heavy hint. I don't know if you caught it. It's subtle. Other questions?
Also,
I like how you're completely running this review.
I'm sorry, I just like have a lot of questions.
No, I'm sure everybody appreciates that.
I saw that there wasn't like optimization on this. Is there going to be optimization on the midterm?
There will be one 5-point problem that is going to feel like an optimization problem.
Okay.
And so that is the only 5 points on the exam that is not well represented in the midterm, and it's just to have something to make you think. But it's going to be the very last question, and you shouldn't waste time on it if you need time for the rest of the things.
Does that include like inverse functions as well?
Yeah, so you will need to know, of course, you'll need to know the derivative of inverse tangent. But you won't need to derive these. You just should have them memorized. So you don't need to know how to come at them from first principles or anything like that. You don't need to know the triangle. You don't need to know the other three. They're off by a minus sign. That's it. But like when I'm asking you about chain rule or logarithmic differentiation or something, I could pick one of these. That's fair game.
If you do pick one of those as like for those two problems, will we have to then explain it if that was the only thing we could do? Because you just said we would, like, you said we could have them memorized, but if it's like...
Yeah, I'm not going to just ask you what the derivative of arctan is.
For like 2 to part C, what's like the answer, like for the limits, ones can just like give an answer for one of them, so it gives you like
Yeah.
limit f of x, I guess x equals 4, like that one.
Yeah.
Or, yeah.
So f of g of 3 is equal to 10. The limit as x goes to 3 of f of g of x. We know that f and g are continuous. We know that f is continuous at 2 and g is continuous at 3 because their derivatives exist. So that means that the limit of their compositions exists and equals the function value there. So like we know that because they're continuous, because they tell us what the derivatives are there, they have to be continuous. And so the limit equals the composition.
So how do you know?
So for
G of 3, okay, yeah, that makes sense.
yeah, so for for the second column, this limit may not exist. We don't know for sure that this limit exists, and that derivative may not exist, and we have no way of knowing what it is.
So that one is like not enough info?
Yeah.
And then for H, is it also the same, or?
Yeah, we also don't have enough information to answer H. And for, I don't really know why this one is C again, but for this one, we have enough information to say that this one does not exist.
Yeah.
But for E and H, we don't know if they exist or not.
Are these answers posted?
No, not yet. So I'll post, like I'm recording this review session right now, I'll post this on YouTube, which is why I did not finish singing the Jeopardy theme song, because I don't want anyone to sue me.
So the reason we say there's not enough information is that we don't know like what the derivatives are?
We don't know if we have continuity for part E there. We don't know that we have continuity of G at 7. And for H, we don't know if we have continuity for G at 5. We do know we have continuity for F at 4, though. There is enough information there to say that we're continuous, that F is continuous at 4. And then, of course, the answer to C is going to be 8. This one we have no way of knowing. And this one we know doesn't exist.
Could you go over number 4?
All right. So obviously there are many answers that are acceptable here. So between -2 so G prime is less than 0 inside here, so negative, 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 and positive outside of there. G double prime is greater than 0 outside of there. so concave up and concave down in here. And also G double prime at -2 can't exist. So I need to be increasing and concave up until -2. Then I've got to start decreasing while remaining concave up. Then I've got to switch and be concave down. Then I've got to switch and be concave up again. And then I'm good. So something like that. Yeah. And now the second derivative at -2 doesn't exist because the first derivative at -2 doesn't exist.
So, because it's like a sharp.
Yeah.
Okay.
The first derivative doesn't exist because it's a sharp point. And then if a function is undefined at a point, its derivative has to be undefined there too.
You could draw that same graph like on the positive, like above the x.
Yeah, I could. There could be any kind of vertical shift.
Can you go back to the set of questions we were just on, with the G of X after that, so plugging stuff in? Yeah, how do you get 8 for C?
Chain rule says that it's f prime of G of 3 times G prime of 3. G of 3 is equal to 2 times G prime of 3. So that's 4 times 2. Other questions?
Could we look over 5CB? One of those logarithmic differentiation problems.
This one? Okay, so if I let y equal that east, then I can take natural log of both sides. And I'll just go ahead and apply laws of logarithms in that same step. So now when I differentiate, So there we go, and then we just need to multiply both sides by y. To get our final answer. Cool. You never had a quiz question on logarithmic differentiation, so it's definitely going to be on the midterm. Other questions?
Could you go over 5A, B? It's like the three products.
So you definitely could use logarithmic differentiation here if you wanted to, but you don't have to. If you don't want to do that, it's best to figure out, or best to make a decision about what you're considering your first function and what you're considering your second function. I'm going to consider the pair e to the x squared as my second function, and the cosecant x as my first function. So this is going to be the first times the derivative of the second. And I'll have to do another product rule in here, but plus the second times the derivative of the first. The derivative of the first is negative cosecant x. Sorry, extra c in there. Cotangent x. The first times the derivative of the second plus the second times the derivative of the first. But if you did logarithmic differentiation, you get the same thing. Believe it or not.
Are you going to be required in the term to use logarithm?
Remember, if you have a function of x to a function of x, that's the only way we can solve those.
Can you do all, oh wait, never mind, that should be all, right, for 5BA. So,
5BA is posted, yeah. So what I did was write the midterm first, and then I took my tech file, which is the program I write math in, and I just changed and made multiples of the questions on the midterm, with the exception of number 6, which I forgot to save the finished product before I posted. So number 6 was the problem that I intended to put on the midterm. So we don't have a lot of examples of that because that's my fault.
Only 6 questions in the two?
Yes.
so we can just have to put number 6 on the midterm.
No, but I did come up with a different one. So, but I mean, no, a different one for us now. So here we want to, let's do all of the things. So we'll sketch. We'll find V and A, and we'll find tangent line when t equals 0.
But this isn't on the midterm.
Huh?
This isn't on the midterm.
This is on the midterm. I mean, this material is. It's just Unfortunately, your practice test does not have multiple parametrics, so I had to pull one that is not on the practice test. So that's why this does not look like it was on your practice test. But remember here, if we square the x and y components, I mean, what I was going to say is still true. It just feels less helpful now. This is equal to e to the negative 2t. Because the sine squared plus cosine squared, when you factor that out, that's just 1. So the distance, so this is also, so now if I took the square root of both sides, I guess, this side is the distance from the origin. And this side is e to the negative t. So this goes to 0. As t goes to infinity. Cosine of 0 is 1. So what this guy is doing is spiraling towards the origin, right? And so this is the point when t equals 0. All right, so now we've sketched it. Next, we'll find the velocity. Derivative of cosine is negative sine plus negative e to the negative t cosine t. I'm going to go ahead and take it back about finding acceleration now. I've changed my mind. That was a terrible idea. But let's go ahead and find the velocity at 0. That's negative 1, 1. Okay. Yeah. And so m is then going to be y over x, which is just negative 1 at that point. So, and then alpha of 0 is equal to 1, 0. So our tangent line is y minus 0 equals negative 1, x minus 1. So when you're finding the equation of the tangent line, you can leave it in point slope form. You don't need to get it in y equals mx plus b form, even though here it's almost done. Other questions?
How do you get velocity? How do you get velocity?
I took the derivative of each component. So this is the derivative of this.
Acceleration should be the velocity, sorry, should be the derivative of the velocity, right?
No, velocity is the derivative of position.
So it's a position function?
Yeah, alpha is the position function.
How did you get that m equals -1? That's so-
I just did y over x.
oh. When you say y over x, you mean for the v of 0, like the one?
Yeah.
Can you go back to the graph, please?
And so if you tried to graph this in your calculator, it definitely does spiral, but it spirals very, very fast, as e to the negative x does as well, so you would have to zoom in a lot. Like I'm looking at units of 100ths right now, and I can only see one spiral. So if you put that in your calculator, it would be hard to see the spiral. I imagine if you go outwards, it's also difficult. That is how exponential growth works, I guess.
That like last question that you said that's like kind of optimization, what's that gonna be like kind of related to? Like, what type? Like, is it like one of the like word problems that we've been doing, or is it a little bit different?
It'll be like one of those.
Do you have like the rest? I didn't get like the rest of like the one with the vote. Do you have that? Or like, is it on OneNote?
I don't think it's on OneNote, but that problem will, how do I want to say this? You could spend a lot of time on it, but if you are spending a lot of time on it, you are doing it wrong.
Okay.
So that's why I said don't plan on spending a lot of time on it. It should be short. So it should be a 5-point problem. Like, it should not be a 10-point problem. All right. Okay. Any other questions? Well, I have to be here for, go ahead. So, f of 2 needs to equal 3. But that limit doesn't exist. F of negative 2 needs to be negative infinity. F of negative 1 needs to be positive 4. I need the limit as we go to 0 from the left to be 1, and the limit as we go to 0 from the right to be negative 1. And I need f of 3 to not exist, so So there are lots of different correct answers. This is as continuous as I feel like I can make it. But you definitely need to have some discontinuity at x goes to 3. You definitely need to have a vertical asymptote at negative 2. And then just check your function values for here and here. And then be sure that those are correct too.
Could you also have like a vertical asymptote at x equals 3 instead?
Sure.
Okay.
At the point 0, 1, why is this circle filled in? Like it's like 11 approaching 0 from the negative.
It doesn't have to be, but it can be.
If it was like not those, like if it was like a circle.
That would be fine. Just make sure both of, like, one of them isn't filled in because it does need to be a function.
One of them is or isn't?
Just make sure that they aren't both filled in.
But can they both not be filled in?
Sure, then it's just not defined there. Unless I say that it's got to be defined on, yeah. I guess in order to make it defined on all real numbers, I would have to put a dot there so that it's still defined at negative 2, but the current graph is defined for all the reals. Function defined by the graph. Other questions?
Can you give an example about the optimization function?
I mean, I can do an optimization problem for you if you'd like. So let's see. Um, 2 meters of wire. Is split to form a square and a circle. Find the way to do this. That maximizes the area. So we have a square that we formed and a circle that we formed. The perimeter has to be 2 meters. It says that it's a square. So if I label the constraints in this way, 2 meters needs to be 4x plus 2 pi r. Right? The circumference of the circle plus the perimeter of the square. And get rid of the m because it's a unit and not a variable. And so 2 minus 2 pi r over 4 is equal to x. So 1 minus pi r over 2 is equal to x. So that's my constraint equation. And now my area equation is going to be x squared plus pi r squared.
The whole thing is squared,
Yeah,
right?
you're right. There should be a 4 on the bottom. Thank you. Okay, do we good here? Pi r over 4, so 5/4. Oh, no. Nope. Just kidding. All right. So at this point, this is an upward facing parabola, right? The leading coefficient is hideous, but it's positive, right? So the graph of the area is going to look something like this. And since we're trying to maximize the area, the maximum is not going to happen when this derivative is equal to 0. It's going to happen at one of the endpoints. Does that make sense? So if at this point you went through the process of taking the derivative, setting it equal to 0, and solving, you would have done a lot of work and made yourself sad for no reason. So let's now think about the domain. So on the one hand, x could be 0, in which case I just have a circle. And on the other hand, r could be 0, in which case I just have a square. Right? So if r were 0, then x would be 0.5. Right, because then the perimeter of the square would just be 2 meters. So now I just need to figure out what the area is for 0 and 0.5. So, so A of, oh, I'm sorry. That's the domain for x. I need the domain for r, which is not going to be as pretty. So it's going to be when 2 pi r is equal to 2. So r is equal to 1 over pi. And now a of 0 is equal to 1/4. And a of 1 over pi is equal to equal to 1 over pi. So the maximum value is when there is no square and there is just a circle.
For the like third part of a equals like 2 how did you get in the parentheses pi squared over 4 plus pi?
I just FOILed and combined like terms. And the only reason I even did that was to illustrate that the area equation gives an upward facing parabola, so that if we took the derivative and set it equal to 0, what we would get would be the minimum, not the maximum.
Yeah, so in that case, if it was a downward facing parabola, then the derivative would be a maximum.
Yeah. I mean, but you know that, right? Like if you graph something, the thing that's higher is bigger. Don't try to memorize anything. And so 1 over pi is larger than 1 over 4. So 1 over pi is going to be your answer. Because pi is smaller than 4, so 1 over pi is bigger than 1 over 4. Any questions? Now, had it been asking me to minimize the area, then I could take the derivative, set it equal to 0, and that would be my minimum. Right, that would have been fine as well.
So when you plug in a of 0 and a of 1 over pi, and you get that 1 over pi is greater than 1 over 4, how did I tell you that you only make a square? So, in that sense.
All right, it's only a circle and no square because r is, because when r equals 0, x is 1/2. I mean, you can look back at this equation here. And when r equals 1 over pi, x is 0. But I mean, that's exactly how we determine the domain. What's the smallest that r can be? Well, r can be so large that there isn't a square anymore. And what's the smallest r can be? R can be 0, in which case there is no circle and the shape is entirely the square. Other questions? All right, so again, I'm going to have office hours tomorrow. I believe I said 9 to 10:30 and then 1:30. I might have said 2, but I meant 3. 1 to 2:30, 1 to 2:30, yeah. So hopefully you don't have class during both of those times.
What's the optimization thing you said on the OneNote?
I'm going to post this video on OneNote. Eager?